This video is on replacing an old GDI malfunctioning fuel pump with a new one here. And to give an overview, the important things are there are these two, there's a 10 millimeter bolt here and a 10 millimeter bolt there, 10 millimeter hex, and they have to be tightened or loosened as close to equally as possible. So to loosen it, you turn like a quarter to a half on one bolt, and then you turn a quarter to a half on the other one, whether you decide to do a quarter or a half, I mean, as long as it's equal. And then until so that's to avoid bending this flange, because those bolts are under, I mean, they're pressing against the camshaft. And one of the things that I didn't do that I should have done is take off the power connection to the to the ignition coil, and probably detach the battery from the car before working on the GDI pump replacement. Okay, it's about 15 degrees outside, and I'm going to start the car, and this is a symptom. Alright, so I'm putting my foot on the brake. Alright. Okay, not a smooth start, even though spark plugs have been replaced, new battery. Alright, I'm going to go with the problem is the GDI pump. And so we're going to replace it when the weather is more conducive. Of course, the engine check light gives the error for low pressure in the fuel rail. And so after the engine's been running now for an hour or so, let's see how well it starts. Usually it starts more quickly. Not that much more quickly. So this is the repair part I'm going to try. So this is the high pressure GDI pump, and just to give an idea what the part numbers are, that I hope I got the right ones. I guess we'll find out. This is an experiment. And so I guess we'll find out and see what happens. GDI pump is under this plastic cover. Alright, so the cover is held on by 4 of these sort of snappy plastic things. Right? So this is the underside of it, and so these are the 4 spots where it's held on, and this here is the GDI. And from what I've learned talking to the parts guy, and so there's this connector here, high pressure, and then there's a bolt here and a bolt here that mounts to the cam, and those 2 bolts are supposed to be taken off slowly, evenly, after these other 3 connectors have been taken care of. And in this particular experiment, I've made sure that the car has not been running for at least 3 hours to hopefully drop the pressure when this connector gets loosened. Okay, so this is 19 millimeters. The 2 bolts that hold it onto the cam, they're 10 millimeter, and I'm going to need diagonal cutting pliers to cut off this zip tie here, and I've already disconnected it at here. I'm not quite sure how this thing, how this thing disconnects from the mount, but I guess I should figure that out. Actually, I won't need to disconnect this from the mount, because when I undo the zip tie here, I can disconnect the cable, and then this should stay with the engine. Alright, and guess I should see what happens. So here are two disconnections made. Alright, so this is zip tie. Yeah, this must be the electrical. When this slid off of here, I'd say a couple of mLs of gasoline squirted out. Alright. And I guess I'll find out what happens next with the 19mm disconnection. And this, after loosening the 19mm nut, alright, so the seal must be with this compression fitting. Alright, and naturally the nut has slid all the way back down here, so I'm going to have to, well, it should be if it slid down, it should be retrievable. Next, this bolt and this bolt evenly loosened. 10mm bolts are on there really tight, so I'm going to have to get a breaker bar assembly. Okay, so this is the old pump replaced. Alright. Okay. Alright, so I'll put some clean motor oil around the O-ring and the shaft for the new pump, and then tighten these screws with my hands. Alright, and now I have to turn each one sequentially half a turn to tighten it to around 20 foot-pounds, or whatever the spec is. And then I'll connect these other nuts. O-ring on the old pump. Alright, so there's that. So some clean motor oil on that, and then some clean motor oil on this part here. Alright, so this connection's been tightened. This has been clipped on again. The electrical. The only thing lacking right now is the zip lock, zip tie for holding this. Alright, I'm going to test it first to see if everything works. And in a side hint, this is my hood holder-upper, because when it gets really cold, the pneumatic hood mechanism doesn't seem to work, and so since this is the first day above freezing in almost a month, it's better to be safe than sorry than have the hood crap up on me. So the typical cheapo broom handle. Alright, now we'll see if it... Okay, so I'm going to have to find out how to clear the error codes, but that's for a later date. Alright, so let's try this. Foot on the brake. Wow, okay. So, sounds like that pump works. Alright, let me turn it off. And let's try it again. Oh, right away. Okay. Alright, so a few things to tidy up, and then finish this repair and find out how to clear the error codes. Hope this helps. Okay, and so since the pump actually seemed to work and provide fuel to the engine, we just got to check to make sure there aren't any leaks. I don't see any. Alright. Okay. I guess mission accomplished. The final part of the installation that I'm doing is I replaced the cable tie that was cut in order to do the disconnection for the power. And the replacement I used are these extreme, these weather-resistant cable ties from Tie Wrap. They're kind of pricey, but they have a temperature rating of from -60 to 105 degrees C, and they're available both at Lowe's or Home Depot. I figure, okay, after going through all of this hassle, better to be safe than sorry. And so the last thing is to put the cover back. And this is the old cable tie here that I cut off. And this is this high temperature one, the one that has a temperature rating from -60 to 105 degrees C. And in order to avoid chewing up the foam or anything, when I connected it here, I swung that head. I don't know if it's visible, but the head is down here. So to avoid any junk up here chewing into the foam that would be around here. And this is the way I do it. I don't know what Hyundai mechanics do, but this is what I'm trying. Cover is back on, and now time for the test after waiting overnight. Alright, time for the GDI test after sitting overnight. And usually it takes about 10 seconds for the car to start. Let's see how it starts now. Foot on the brake. Look at that, within 2 seconds. So, from my perspective, it's a success. This is a follow-up test on a 2012 Hyundai Sonata 2-liter turbo, in which I've replaced the GDI high-pressure pump. And on the new pump, I have approximately 60 miles on it. So let's see how easy it starts. Alright, so I'm going to put foot on the brake, press. Starts within a couple seconds. So I wonder how long this GDI pump will last. After putting 150 miles on the new GDI pump, there are a couple of things I probably would do differently if I had to do this again. One is I would make sure that the pressure drop in the fuel line was really there, that the fuel line really was depressurized. And there's a quick video on YouTube that goes over this. The reason I didn't do it is because when I would start the car, it would take about 10 seconds of cranking before it would start. And so my thoughts were that, given this experience, if I just let the car sit overnight with the engine turned off, that it would depressurize significantly, so that when I did make that disconnection of the fuel line, that there essentially wouldn't be any fuel coming out. And yeah, there were a few drops, at most 2 mL, and but it's probably not the prudent thing to do. The second thing is I would disconnect the battery. That video also goes over that, and that probably is a more prudent safety action. Although, if after you determine that the new GDI pump is okay and works fine, change the engine oil. The engine oil that I had with the old GDI pump was so gross and dirty after only 1,800 miles that it caused me some concern.